Hello everyone, how are you? Do you have my voice? Oh, hi, good morning. Okay, so nice. Can I start? Can I start the session? Okay. So, as you remember, previous session we talked about LCD, and I think we had one or more than one codes related to LCD. Anyway, today I want to continue my discussion with different codes related to the LCD, and also I want to work with Code Wizard, as you remember previous sessions when we were coding LED and also LCD. I said that because we want to have sufficient information about different types of coding without using Code Wizard. I didn't use Code Wizard of Code Vision, but today when I'm trying to write the code in Code Vision, I use Code Wizard. So here, as you see in the slide, there is another code example related to LCD. Wants us to write a program to print micro and shift it to right side or right hand 5 times. And the code wants us to use Code Wizard. Uh, Let me turn on the cursor. Okay. We said that for starting each kind of program, we need to have the preprocessor related, which are required in that program. For example, we want to write our code in at Mega 16. Then we should add the header file related to the Mega 16 or the library related to the Mega 16 by using this preprocessor. Moreover, we said that about LCD, we need to add the library of LCD to our code. This is the library of LCD which should be added. And also we said that every function, every code in our coding is including one main function. And because we want to only print something in LCD, then we don't have, we will not have a return type main function, and it is void type. However, I explained about them in a previous session when we were talking about the different types of functions. Moreover, as I remember, I talked about different types of LCDs and initializing of LCD. And we said that we need to initialize LCD because we are using the 16 by 2 LCD. Then we should write this code. And why 16? Because the number of the columns that are used in our LCD is 16. However, if the number of the columns of LCD, for example, would be 40, then meaning that our LCD would be 40 by 4 LCD, then here we should write 4T. Don't forget to write a semicolon here. Then the rest of the code is related to the example, meaning that the content that example wants us to write in our coding and execute it in our Code Vision. It wants us to print a micro and shift it to right side 5 times. We know that for printing a string, we use LCD putsdef. Okay, inside the parentheses and double quotation. We don't have any problem about this section. Also, we said that we use LCD clear function because we want to see that something is appeared in our LCD's screen and also it is disappeared. But we need to write a code to shift micro to right hand 5 times. To do that, we need to write a for a statement or a control statement related to for a statement. I wrote here the code related to this section, meaning that shifting micro to right side 5 times. For I equals 0, this is initial value of for statement, and this is condition I less than or equal 5. Why 5? Because it wants to shift it to right side 5 times, and in each step, one integer number increase the I. Then the curly braces is open and LCD clear. LCD, this is setting the cursor of LCD. I talked about it in a previous session, but here the number of column is changing between 0 till to 5. Then instead of number of column for setting the cursor place or location, we wrote I and 0. 0 is related to which argument? Could you please cooperate with class? 0 here, what we mean with 0 in this function? No, it is related to row, because our thank you very much for being in class. Yes, one of these arguments is related to the cursor setting location on column, and the other is related to the row. We are using 16 column and 2 row LCD. When we are talking about moving or shifting, sorry, a moment. Shifting the micro to left side, meaning that it is moving in the columns of LCD. I'll show you when I am going to pretty-use to simulate it. And 0 is related to first row of our LCD, which is including only 2 rows. So, and the rest of the code, LCD puts F inside the parentheses and double quotation. We wrote micro. However, this is related to our previous session discussion, and we're creating a delay which is equal 1,000 millisecond or 1 second. Or also we can use different seconds here, because it doesn't mention that this shifting to right side, for example, takes 1 second. For example, we can use 200 millisecond or any time that we wish. If we write this code, this part, this section, meaning that writing micro on our LCD screen is written in LCD screen, and it is shifted from first column to 6th column, and then the coding or the execution of the program is finished. But when we are writing this program, meaning that when we are trying to write this code inside of while one, actually we can have looping structure to create infinite loop of execution of this content, meaning that shifting micro to right side 5 times and again coming back to first column, and again shifting to right side 5 times and coming back to first column, and it is repeated infinite time. Why? Because we are using while one is creating infinite conditional loop. No, we should write it because we need to shift when we are shifting. We are trying to move from first column to sixth column. We should show that in first column, for example, the micro is deleted, and in second column it is shown. Then to do that, we need to add LCD clear, and also we need to add delay. Let me to see again. No, we should write it because, as I said, if we don't write it, we can't say we can't a moment, please. Please don't interrupt me because when I'm going to start with Code Vision and Pretuse, I will talk about them, and you can ask your questions, meaning that we can test them in our Code Vision. As you see, by using this code, meaning that adding while one, we can have infinite and conditional execution. And by using this code one time, it is this statement is happened, and then the code is finished, or execution is, or compiling of the code is finished. So here we have another code wants us to write a program to print welcome at the top and middle part of LCD. Welcome is including how many letters? 1, 2, 3, 4, 5, 6, 7. It is including 7 letters. Our LCD is including how many columns? The LCD which we are using is including how many columns? 16. Very nice. Yes. Then what does it mean? It means that for having or for printing welcome at middle part of LCD, at top of LCD means that our LCDs is including 2 rows. When it's talking about top of LCD, it means that we write it in first column. And to do that, only it's required to set the cursor in 0 row, which is indexed by 0, and it means that it is first row. But when it wants us to print welcome in middle part of LCD, because our LCD is including 16 columns, then it's better for having it in middle part of LCD. Then we subscribe the number of letters from 16, and then sorry, a moment. Do you have my voice? Uh, is my voice clear? Okay, sorry, I forgot to open the microphone. Yes, thank you for letting me know. Uh, it's not clear. I don't understand. For all of the students, my voice is not clear. I mean, are you in class? Do you have my voice? Okay, then wait for 5 or 6 minutes, and again we'll restart our class. Thank you. Sorry, do you have my voice? Is it clear? Still the same problem, meaning that. Okay, then again, wait 3 or 4 minutes. Again, do you have my voice? Okay, is it clear sufficient? Then I continue. So very nice, thank you. So again here, wants us to write a program to print welcome at the top and middle port of LCD and then print Istanbul and shift it to right side 8 times and repeat it infinite times. It wants us to use a code wizard, so we will have the same procedure, somehow the same with the previous code. We should add a preprocessor or the library related to Atmega 16. We need to add a library related to the LCD. And also because we are using a delay in our code, the delay library should be added to our code. And also we will have one main function, and it is void type main function. We should have initializing of LCD as you see here. We initialize it. All of these part is the same with previous code that we wrote here. Because we are using as a same with previous code, because we are using a variable I, then it should be declared as local or global. Here you see that I used it as global. However, we can use it as local. it doesn't make any difference to use int I as a local or global. But if you don't use it, you will have error in your programming. Then, as I said, welcome is including how many letters? It is including 7 letters. LCD is including 16 column. Okay, 16 minus 7 would be equal 9. 9 over 2 would be equal 4.5. But because our columns, as I said, are integer numbers, starting from 0 to 15, then the value for 4.5 is chosen as 4. Then the cursor setting location would be as this argument inside the parentheses. The welcome should be written or printed at top and middle part of LCD. For writing it at top of LCD, we choose the first row. Then first row index is starting from 0, and middle part, as I said, the number of columns minus the number of the letters of welcome, which is equal 7, would be equal 9. 9 over 2 is exactly pointing to middle part of LCD, which is indexed by 4. Again, LCD puts F welcome. Again, delay millisecond, but wants us in the rest of the code wants us then print Istanbul and shift it to right hand 8 times and repeat it infinite times. Because it wants to repeat it infinite times, we should have while one. As you see, I wrote all of the codes inside while one, and this is why because the code wants us to repeat it infinite times. Moreover, in the rest of after printing welcome, we have the rest of the code, as I said, wants us to print Istanbul and shift it to right hand 8 times. To do that, as previous code, we use this coding for I equals 0, I less than equal 8, I plus plus, and LCD clear. LCD go to X, Y. I and 0, and the LCD puts F Istanbul and delay of 1 second or 1000 millisecond. As you see in the codes, one of the curly braces is related to void main. The other one is related to while infinite unconditional. And the other the last curly braces is related to for statement. All of them should be closed. Now, one of the students, I think Amina, asked me why we don't choose a part, why we don't write the code related to choosing a port for interfacing microcontroller with LCD. The reason will be explained when I'm starting to open code vision, because in a previous session when we were coding our LCD, we didn't use code wizard, and then for interfacing or for initializing a port with our LCD, we wrote a code related to each of the ports, port A, B, C, D. We wrote the code in assembly in our coding and our program. But here, because we are using Code Wizard, in Code Wizard there is an choices. There are choices. There is an option to choose our port, and then it's not required to write the assembly code related to interfacing one port, for example, port A with our LCD. Then let me okay. I'm starting code vision. Do you see it? Okay, very nice. So we said that for writing our program, it's required to go File, New Project. Okay. In this step, it wants us, do you want to answer to this question? Do you want to use Code Wizard? Yes. Today we want to use it. Okay, here in Code Wizard section, there are two categories. One of the categories is related to the chip types of our AVR, 80, 90, a tiny and 80 mega. The other category is related to X mega. Do we are working with X mega? No, we are working with at mega 16 or 32. Then it means that please don't make changes in this section and choose the first type or category related to at mega, and then okay. So here, the type of chip should be, or the type of AVR should be chosen. For example, we want to use at mega 16. We want to use, we want to use at mega 32. All the types are here. For example, at mega 32 is here. Yes, it's related to your code. If your code, let me to check my code, that my code is, let me, I want to see that I wrote the code for at mega 16. Yes, we wrote the code for at mega 16 in second code, and in first code again for at mega 16. Then here, what happened? I'm starting again. File, New Project. Do you want to use Code Wizard? Yes. The first type category is including at mega, then okay. Okay. Here, the type of chip should be chosen because we are coding or writing a program for at mega 16, and we want to interface our LCD with at mega 16. I choose at mega 16 here, at mega 16. We said that the clock in your code vision and code wizard section most probably is set it to be 8. If it is 8, please change it to 1 megahertz, because as I explained in a previous session, the available AVRs in the market, real AVRs that we are using in laboratory as experimental, or their clock are set it to be equal 1 megahertz. Then when you write the code for 8 megahertz, the clock for 8 megahertz, then you will have problem about creating delay, meaning that the delay that you're creating will be less than your desired or more than it. So it's better to set it to 1 megahertz because, as I said, as a default, the types which are existing in the market are set it to be equal 1 megahertz. Then, as you see in left hand, we have some options. For example, the ports. Here, different ports of at mega 16 that we choose it are shown. As you remember, for our coding related to programming, we use for initializing, or on the other hand, for configuring a code as input and output, we wrote a code. For example, when we want to have port A as input, we use which register? For example, when we want to have port A, all of the bits as input, we use which register and which code? Let me...
Is it DDR?
Yes, very nice. Thank you very much. We use DDR register, and we set it to 0x, for example, 00, for configuring it or setting it as input register. But Code Wizard gives us some opportunity, meaning that choosing the ports as input and output. And also, when we said that, for example, when we choose, for example, here bit 0, bit 1, bit 2, up to bit 7, all of 8 bits of port A are set it or configured as input. For example, I want to have bit 1 of port A as output. Then by clicking on that, one click on that, we can set it as output. Or for example, I want to have bit 5 of port A as output. Or for example, about port B, I want to set all of the bits of port B as output. For example, you see that here I set all of them as output. Or for example, to have port C also all of the bits as output. However, as you remember, when we were coding without using Code Wizard, we write the code related to DDR register. And for example, for having as output all of the bits of one port, for example, port B, we wrote, for example, DDRB and 0xFF for all of the bits are used, meaning that all of the bits values are equal 1. It means that by having 1, it's configured as all of the bits are configured as output. Moreover, we said that there is another option related to, for example, suppose that about port B, 4 first bits are configured as input, and 4 next bits are configured as output. We said that when bits of a port or all of the bits of a port are configured as input, for example, these 4 bits, then we have we can have pull up resistor activated, or we can have it as tree state or floating. These options here, as you see, for 4 first bits, bit 0, 1, 2, 3, gives such opportunity. As you remember, we used port register for activating pull-up resistor when the bits of one port is configured as input. and we set it to 1 when we want to activate it as activate its pull-up resistor, and we set it to 0 when we want to not activate the pull-up resistor, or we want to have it as fluting. And also, when the port bits are configured as output, again, by using port register, we determine the initial value for the bits of that port. For example, when it was written 0 in our coding, it means that it has a 0 volt. And when it's written as 1 in port register, it means that it has 5 volt. But here, by choosing it as 1, for example, for all of the output bits of port C, sorry, I'm talking about port C, you see that this port is activated. It means that all these 4 bits which are configured as output has initial value which is high or 5 volt. And all these 4 bits, first 4 bits, which are configured as input, don't have a pull-up resistor activated. And by pressing on these buttons, actually I activate pull-up resistor. Then this column is related to pull-up resistor when it is configured as input, or output value when it is configured as output, and this column is related to data direction that we actually write the code by using DDR-X register for configuring a port as input and output, and this column, as I said, is related to port X register duty. So again, about the port D, we will have the same options, data direction and pull up or output value. So I want to have all of them, return all of them to their default values. Port all of them as input, and their pull-up resistor aren't activated or is fluting. Port C, again, all of them input, pull-up resistor not activated or fluting or tri-state. Port B, again, input and tri-state. Port A, input and tri-state. Then you have sufficient information to configuring a port as input and output, and also activating pull-up resistor when it is input, or giving output value to that. Moreover, you see here the other options, for example, timer counter, the analog to digital converter. All of them are actually related properties that Code Wizard gives us. So this is Code Wizard window. You see that on top of that it's written Code Wizard of AVR. But today we want to use which device which is connected to our LCD. Sorry, with our AVR. We want to use LCD, and then I choose the option which is in left side in this column, and it is called alphanumeric LCD, and I try for enabling alphanumeric LCD. Then some options are shown in this window. Here you can see that there is an option choice related to characters and lines. This is related to the columns of our LCD. How many columns our LCD's types is 16 by 2. Then the number of columns for initializing of LCD is equal 16. Then here we are searching for 16. You see that it is 16 and choose it. If we, for example, we are using 14 by 4 LCD, then we should choose 40. But because the type of LCD that we are interfacing with our AVR is 16, using a 16 column, then I choose this option as 16. This is controller type. Actually, in real AVRs, when you buy from the market, in the behind of them, in real LCDs, when you're buying from the market, you can see that in behind of them there is a chip. These chips are actually these two types, but because the available LCDs in the market are using this type of chips, HD44780, then it's not required to change the value of the type of the chip to KS0073 type. And it's this type of controller for LCD chip is correct type, and it's related to the LCD chips that you have, and it is available in your laboratory or in your devices that when you want to interface it with your AVR. Then this option is not required to be changed, because as I said, the available LCDs chips is this type. These chips actually, what is the duty of this chip? You know that when we write the code, we are writing the code in C language in our AVR, but in LCD we shows the LCD shows us graphics, letters, numbers, and something like this. Then the codes in C language actually converted to the graphic or letters and characters and something like this. All conversion are done by this chip, which is installed in the behind of LCD. So here is the answer of the questions that Amina asked me when I was talking about the code related to the interfacing of LCD with AVR. He said that why we don't write the code related to configuring a port to interfacing with the our microcontroller with the LCD, and I said that the reason is that we are using Code Wizard, because in Code Wizard we have some options that we can have some choices, and then it's not required to write the code related to that, meaning that Code Wizard automatically generate some codes, and then it's not required to write some codes by our hands. So you see here, for example, we want to interface our LCD with port A of our AVR at Mega 16. Then here it's required to choose port A. Or for example, I want to interface the LCD with port B of our AVR. You see that I choose all of them as port B. And then it's not required in my coding to configure port B, the code related to configuring port B to interfacing with LCD. Because I want to use port A to interface with my LCD, then I change all of them to port A. However, for example, you can choose any other port. There are different choices: port D, port C, port B, port A. We want to use to interface or connect port A bits to our LCD, and here there is a connection of different bits of port A with LCD. For example, RAS and RD, which are control pins of LCD, and also EAN are control bits of LCD, which are connected respectively to bit 0, bit 1, and bit 2. However, we can do some changes about them, but it's not required. Don't make your interfacing so difficult. And we said that we are using 4-bit type for interfacing of LCD with AVR. Then this is D4, D5, D6, and D7, which are connected to bit 4, 5, 6, 7 of port A of our AVR. Do you have any question? There are so easy. Actually, we are doing some choices here, and then they will be executed or generated code wizard. So here, after doing these changes, meaning that yes. We went to alphanumeric LCD section, and then we enabled alphanumeric LCD support. After enabling it, some choices are shown for us. We don't change the controller type, but we change the characters lines with respect to the types of LCD that we are using, because we are using 16 by 2 LCD. Then the columns number is equal 16, and we choose 16 from these options. And then here we can choose the ports related to the LCD. And after that, we come here to program and generate. You see that here Code Wizard generate the codes for us. What is the generated code? The Atmega 16 that we choose as our AVR. Also, we initialized enable alphanumeric LCD and initialized LCD. Then it's not required to write this code, because it is generated by our code wizard. We said that the comments after double slash isn't important, and we can delete them. You see that I'm deleting all of them. Also, you see that here, this, for example, this is more explanation about Code Wizard, some codings. As you remember, we use the DDR register for configuring one port as input or output, or some of the bits of one port as input and output. And we said that, for example, when we want to have all of the bits, all 8 bits of port A as input, we are using DDRA equal 0x00, meaning that all of the bits of port A are configured as input. However, there is another way or method for configuring the ports of the bits of one port as input or output, and this is that way. However, it is so difficult and it's complicated. I don't suggest you and refer you to try to use this kind of coding, but I wanted to have some explanation to about this one, to not be confused when you're seeing the code something like this. Anyway, there are, as you see, after double slash, and we don't need to them. Thank you. We appreciate Code Wizard, but we don't need to them. And then we delete all of them. You see, I delete it, but please be careful to not to delete the curly braces related to main function. Also, you see that these are also the explanations related to the connections and after double slash. But I suggest you don't raise the connections or don't delete the codes or comments related to the connections. Bit 0 is connected to RS. Bit 1 is connected to RAD. Bit 2 of port A is connected to EN, the control bits or pins of LCD, and these are data pins of LCD which are connected respectively to bit 4, 5, 6, 7 of port A. Why I suggest you to not erase them? Because if you erase them, for example, you erase them, and you erased all of them, okay, and then you have a prototype or experimental result of interfacing your LCD with AVR. Suppose that after getting your results, you put your circuit in one side, and then someone's come to the laboratory and disconnect your connections. Meaning that you did some wiring in experimental, and someone's to the laboratory and don't have sufficient information about it is your work, and then disconnect your wiring. Then when you started to do the connections or make the connections between the pins of the ports, the interface port, and also with the LCD, you don't know you write the code for which pin, and then you should connect which pin of LCD to which bit of your AVR. Then to do that, it's better to have these connections, meaning that by having the explanation related to the connection, even if your circuit related to experimental would be disconnected, you can connect them by using these commands. And you see that this is initializing of LCD, which is also generated by Code Wizard. We appreciate it. And the inside while one, there was a double slash and some explanation and some command that I raised it. Again, I come to program in top of the Code Wizard. And I press generate, save, and exit. Okay. In this section, you see that when we are using Code Wizard, at first, don't want you to save your file. After choosing some options and some choices, the Code Wizard wants you to save your files. We said that we generate one file, one general file. For example, LCD, and then inside LCD, I generate one file related to the code, and also I generate another file related to my Proteus, okay, simulation. Again, inside the code, sorry, inside the code, about using Code Wizard, we should generate 3 files: LCD, save, again LCD, save, wait, again LCD, and save. Okay, now our code is generated, and these are extra explanations. This is also the sum command, and this is a preprocessor related to the library of Mega 16 header file, LCD header file. Again, some commands, and it's better to be erased, but be careful when you're erasing and deleting the command codes. Don't erase the main sections of your coding. And we said that these are not required. Again, okay, only we hold the connections of AVR port E bits, port A bits with LCD pins, and then this section should be in our code, and that's all. Now we are going to our code. The first code wants us to write a program to print micro and shift it to right side 5 times. As you see, this section in Code Wizard, we choose at Mega 16, and this is generated by Code Wizard. If we go to Code Vision, you can see that this preprocessor is added by Code Wizard to our codes, and it's not required to write it. Moreover, the LCD library also is added by Code Wizard to our code. You can see this one. Moreover, we have the void main void function in our Code Wizard. You can see it here. Also, the LCD initializing with some choices in our alphanumeric LCD section of Code Wizard is also done. If you see here, you can find the code related to initializing of LCD. Then these are not required to written by hand, because Code Wizard is generated them, and then only the required codes should be written. What are the required codes? Because we are generating some delays, then we should add the library related to the delay, or delay function. Okay, then here I add the preprocessor related to delay header file. Moreover, what we need, because we are using a variable I, it is required to initialize or declare variable I. Again, I'm going here. I declare it as global variable, but we can have it as local variable. It doesn't make any difference. One more thing, the codes that we wrote from here to here. Control C. Okay, at first we said that we don't want to have repeated code. Then I delete while function here, and then I only add for. Void is started by one curly braces, then it should be uh, closed by one curly braces. Moreover, for a statement is started by one curly braces and it should be closed. Then we have one curly braces opened for void main and one for statement. Then we have one curly braces which is closing main function, and we have another one for closing for statement. Let me to check our code that is it something to required to add to our codes? Nothing else in this step. And let me compile it. Then you can see that we don't have any warning, and then the coding section is finished. Only it's required to go to which step to simulation in Proteus. Again, file, new project. We should browse the section that we saved our file, Proteus, and I want to call it LCD. Okay, here again we should choose one LCD. I said that for LCD it's better to search LM0. I searched LM0. I'm using 16 by 2 alphanumeric LCD. Then by double click on that, it comes to my library. Again, I need at mega 16. At mega 16 is here, and by double click on that, let me yes let me to see that. Yes, very nice. And LCD is connected to which port? As you remember, when we are trying to choose one port to interface with the LCD in Code Wizard setting, we choose port A. And also, let me to show you in the program in the comments part that I didn't raise it. You see that port A, all of the bits are connected to our LCD, and that's why I said that it's better to not erase these commands. Then I put LCD here near to port A because port A is here. So I start to have my connections according to Code Wizard setting. Bit 0, bit 1, and bit 2 are respectively to connected RAS, RAD, and EAN. Then I start to have their connections. Okay, moreover, let's to see bit 4, 5, 6, 7 of our port A is connected to data bit 4, 5, 6, 7. Data bit 4, 5, 6, 7. I start from the last one. Okay. D4 is connected to bit 4. D5, you see that D5 is connected to bit 5 of port A, and D6 is connected to bit 6, and D7 is connected to bit 7 of port A. And you see that one of the bits, bit 3, is no connection. And you see that here 0, 1, 2, and 3 is not connected to any pins of LCD. It's starting from 0, 1, 2, and then 3 is not connected, 4, 5, 6, 7. So we compiled our code. It doesn't have any error. Only it's required to go and convert the code to our AVR. It was inside LCD code debug exe hex. Okay. You see that, I want to restart it again. You see that micro from first column is starting and going 5 times to right hand and then stop. Why it's stop and not repeated? Why? Do you know why? Please open the microphone. I don't want to go to
There's no
that.
while loop.
Yes,
Make it
yes, thank you
infinite.
very much. Yes, yes, thank you very much. Then what does it mean? It means that for repeating that, we need to add this code while one for creating what? For creating looping structure and infinite loop of execution. Then only by adding while or putting this code inside the while one, we can repeat it infinite times, and then only it's required to write while one, as you see here, while one inside the parentheses, curly braces on, open, and curly braces is closed. Okay, I compiled it. Again, you see that there isn't any warning or error. Again, I go to my previous simulation. The same code is executing, but this time it's not stopped. You see that it is starting from 0 column. These are the columns of our LCD. It is including 16 columns and 2 rows. One row is the row related to that micro is presented on that, and the below of micro row is the second row of 16 by 2 LCD. So you see that this is not stopped because we added what to our coding, while one to our coding. But be careful, while one coding is included, one curly braces opened and one curly braces closed. So we can have this moving with high speed, I choose the 200 millisecond instead of 1000 millisecond, and I compile the code again and go to my Proteus, and you can see that what happened. The speed is increased related to shifting micro from 0 column to 5th column. Okay, let's go to second code. About the second code, when we are using with the code wizard, we will have the same procedure. We choose, for example, Mega 16. We actually activate alphanumeric LCD, and then what happened in code wizard, these codes, the green typed codes, are generated by code wizard. Then only it's required to add the other sections of our code. Again, because we said that it wants us to repeat it infinite times, we have while function, while one function, or while one infinite unconditional statement. And you see here, then only it's required to do what? To copy this section of code that I explained it in the slides to our code vision. Okay, you see that I didn't do any changes about this section. Only the main content of the code is related to next example, is added to our program, and it's replaced with our previous program. So I want to, I think one of the curly braces, yes. Yes, you see that we don't have any errors. I didn't write one of the curly braces, and it's shown me one error because we have one main function. You see that one main function, one curly braces open. We have one while infinite unfunctional statement, and then the curly braces related to that. Then the second one, and we have for statement and curly braces related to that. This is the third one, and then we should have the third curly braces, which are the three curly braces which are closed. So we compiled it or executed, and then we come to our code, and then start to our coding. You see that at first time it wrote welcome in top and middle part of LCD, and then wrote Istanbul from one column. You see that welcome in top and middle part of LCD, and then printed Istanbul from first column or column 0 till up to last column or column 15 of LCD. However, we can have some changes. For example, instead of welcome, I can write Okan. Okan is including how many letters? 1, 2, 3, 5. Am I right? It is including how 5 letters. I want to have Okan at middle and top of my LCD. Okan is including 5 letters. The LCD is including how many columns? 16 columns. 16 minus 5 would be equal 11. 11 over 2 would be equal 5.5, but we consider it as 5. Then LCD go to x, y should be equal with what?
5.
Very nice, thank you. And if I want to have it in bottom of LCD, we should write here which number?
1.
Not in top of. Very nice. We should write 1. Let's decompile it. You see that Okan is typed in bottom of LCD, meaning that in second row of LCD, and then Istanbul is printed from first column, and it's going to the last column of LCD. Any question? Do you have any question? Okay. Who was answering me? Amina, are you are answering me? Okay. Okay. Thank you very much for cooperating. Thank you, Ismail. Yes, I know you. You're always are attending to the class and asking your question and cooperating with class. Thank you for your cooperation and thank you. And also trying to learn something. Uh, uh, Mahmoud, about the final, actually, I wanted to have it as multiple choice again because I tried to have it as experimental, meaning that in laboratory, but unfortunately, we don't have such an opportunity. The number of the students are too much, and then we don't have such an opportunity. I'll try to have if I can create the questions from the codes. I don't know how I can have the codes as multiple choice questions. Anyway, if I can, I will have multiple choice exam. If it would be as online, I will send email by OIS to all of the students. Yes, of course, of course. Next week, when you're trying to attend to the class, I will let you know about the final exam, and also I will send the format of the exam for all of the students by email on OIS. Thank you very much. Have a nice time. If you don't have any question, we can finish the class. Thank you, Amina. Uh, thank you very much. Thank you for your cooperation, really. Thank you. Have a nice time. See you. Bye bye.